In today's lesson, section 7.7, we're going to look at extending this idea of sine, cosine, and tangent and using them to solve right triangles. In other words, we're going to use sine, cosine, and tangent now to not only solve for side lengths in a right triangle, but we're also going to use sine, cosine, and tangent to solve for angle measures. Okay, so the idea is that by the end of the lesson today, you'll be able to successfully use inverse tangent, inverse sine, and inverse cosine to solve right triangles. Okay. So here's the idea of inverse trig. We're going to set up our equation exactly like we've been. Okay. The only difference now is we're going to be solving for an angle measure. And the biggest thing that you need to understand is that if you want to get rid of sine, cosine, or tangent on one side of the equation, then what you do is you utilize the inverse sine, the inverse cosine, and the inverse tangent, like you can see here. Okay, and this will make more sense as we go through and work through a couple of examples. I may explain it slightly differently than other teachers, but this, I believe, is the best way for all of you to understand how the inverse sine, inverse cosine, inverse tangent all work. Okay. Again, the biggest thing is I can't emphasize this enough, and I'll continue to say it throughout this video and in class tomorrow. If you're solving for an angle measure, you are using inverse tangent, inverse sine, or inverse cosine. Okay, so it says use the calculator to approximate the measures of angles A and B to the nearest tenth of a degree. So all we're going to do here, again, since this says sine of A equals this number, our goal is to solve for this A here. I want to get A by itself, so I got to get rid of this sin, and the way you get rid of sine is you do sine -1 or inverse sine of both sides. Okay, and so angle A, the measure of angle A, equals the inverse sine of this decimal, 0.7624. And at that point, you go ahead and grab a calculator, and now it's just a plug and chug problem. Okay, now when you do inverse sine, inverse cosine, inverse tangent, you're going to hit the second button or the shift button on your calculator, and that will get you the -1. Okay, and so you'll use inverse sine of 0.7624, hit enter, and if my calculator is correct, which I'm sure it is, this angle measure here is roughly 49.7 degrees. All right, and so that's how we're going to solve for angle measures. Again, if you're solving for an angle, you're using inverse. Part B, go ahead at this time. You may want to pause the video and just identify what the measure of angle B is. So if I'm you, pause the video, find the measure of angle B, and then continue playing this video to make sure you did it correctly. So again, we identify we're solving for this B. I got to get rid of the cosine, and so in this particular example, I'm going to take the inverse cosine, cosine -1 of both sides. So B equals the inverse cosine of 0.1783. And again, you bust out the calculator. Second cosine 0.1783, enter, and I believe you should get something pretty close to 79.7 degrees. All right, so hopefully this is starting to catch on a little bit. And then part C, go ahead and do on your own. And again, if you have any questions on that one, bring it to class tomorrow. But again, you're solving for an angle measure, so you're going to use inverse trig. Again, this is pretty basic stuff. I'm not actually going to do any of these. This is actually just kind of the same idea that we just did. So again, work through this example on your own. This is just getting you used to the calculator and knowing where the inverse sine, inverse cosine, and inverse tangent buttons are. Every calculator is slightly different. So if you're not sure where your inverse buttons are, make sure you bring those questions to class tomorrow, and I'll help you out. All right. So here's kind of like this is the real use of these functions, okay, or of the inverse ratios. So it says use a calculator to approximate the measure of angle A and C to the nearest tenth of a degree. So in other words, here's angle A, right? I got to solve for angle A. Well, I know 16, that's my opposite side. I know 20, that's my adjacent side. And so if you're thinking opposite adjacent, go back to SOHCAHTOA. Opposite adjacent tells you to use tangent. So we take tangent of our angle. We don't know our angle here. We just call it tangent of A equals opposite over adjacent. And now again, I got to get this A by itself. And so I take the inverse tan of both sides. Tan -1, both sides. Tan -1 and tan essentially cancel each other out. And so what we're left with now is A equals tan -1, 16 over 20. You can just leave it as 16 over 20, or you can reduce it down. Either way, the calculator is going to get you the same answer. And so now at this point, you go to your calculator. I hit second tangent, 16 divided by 20, hit enter. I did that wrong. Make sure you put your 16 over 20 in parentheses. So second tan -1, parentheses, 16 divided by 20, parentheses, enter. And I believe you should get something pretty close to 38.7 degrees here for angle A. Okay, so angle A, I'm going to go ahead and erase some of this. Angle A is 38.7 degrees. All right, and then it says approximate the measure of angle C. A couple ways of doing that one. The easiest way, and the way that we'll do it, is we know that angle B, angle A, and angle C have to add up to 180. And so I know I have 90. I have 90 plus the 38.7 plus the measure of angle C has to equal 180, and then I just solve this. So long story short, I get the measure of angle C equals, I have 180 minus 90 minus 38.7, and I'm pretty sure that tells me that measure of angle C has to be pretty close to 51.3 degrees. All right, so just kind of an idea there in terms of how we're going to use inverse trig to solve various triangles. Again, for example 4, these are going to be for you guys to work on. I'm going to go ahead and do part A right now. So if you think you have this, I would challenge you to, actually, we'll do part B. Part A is very similar to the one we just did. We'll do part B. Our task is to solve for the measure of angle A. And so, again, if you think you have it, go ahead and pause the video, work through this example, and then play it to make sure you're doing it correctly. If you're not sure, just keep plugging along with me here, okay? So the first thing I do is I look at it. This is the angle I'm trying to find. I know this is my hypotenuse. I know the 14 represents the adjacent side. So katoa, AH, tells me to use cosine. So the cosine of A equals adjacent over hypotenuse. And now from here again, I got to get rid of the cos, the COS, and so the only way to do that is to do the inverse cosine of both sides. So these two essentially cancel each other out, and what I'm left with now is A equals the inverse cosine of 14 over 25. Sorry about that. And again, at that point, just grab your calculator, second cosine, parentheses, make sure you put in parentheses, 14 over 25, hit enter, and I'm pretty sure the measure of angle A here should be pretty close to 55.9 degrees, okay, to the nearest tenth. All right, again, part C is there for you to kind of take a look at and just practice on your own. Again, any issues you have, bring them to class and we'll get those questions answered. Now we're going to start getting into more application type problems, story problems, word problems. All right, we're going to see a lot of word problems the next couple days. So it says solve the right triangle, find BC and AC, and round decimal answers to the nearest tenth. Okay, so when it says solve the right triangle, that means find all missing sides and angles. All right, so immediately the first thing I can identify is, hey, I need to find this angle measure here. All right, well, that should be a pretty simple task because, again, we already know from first semester that the angles in a triangle add up to 180. So I have 180 minus 90 minus 23 tells me this angle up here has to be 67 degrees. All right, I'm done there. Now I got to find BC and AC. Call them X and Y. All right, pick one and solve for that one first. So I'm going to say let's go ahead and solve for X. Okay, identify the angle you want to use. I always like using what they give me. It makes it easy, and so I'm going to use this 23-degree angle. If I use that 23-degree angle, I'm trying to find this X. The X happens to be the adjacent side. And the only other side I know is this 40, and that 40 happens to be the hypotenuse. If I'm using adjacent and hypotenuse, that tells me that I'm going to go ahead and I'm going to use cosine. So to solve for x here, which is AC, okay, I'm going to say that the cosine of my angle, so the cosine of 23 is equal to adjacent, we don't know it, divided by hypotenuse. And remember our process here, put this guy over 1, cross multiply, you get x equals 40 times the cosine of 23 degrees. And again, at that point, just grab your calculator, 40 times cos 23. Hopefully yours is giving you the same answer mine is. Mine's telling me that this thing is roughly 36 point, and again, it said round to the nearest tenth up here, so 36.8, okay, and make sure we have units on that thing. It's feet. Okay, so that's roughly the length of AC. And finally, I have to do BC. One thing I would encourage you all, do not use the Pythagorean theorem because, again, I've already said this over and over in class, but this 36.8 here, that's an estimate. Okay, we don't know. That's not an exact answer. So I want to be as close to the exact answer as possible. So I'm not going to use a value that I found on my own. I'm just going to use everything that the diagram gives me. Okay, and so now I got to go back. I reset. Now my task is I want to solve for y. Okay, well, again, it just depends on what angle you want to use. I'm still going to keep using my 23 because that's the way I see it. You could use the 67 and that would change your problem a little bit, but still get the same answer. So anyway, the y here represents the opposite side, and obviously we still know our 40 is our hypotenuse. Opposite hypotenuse tells me to use cosine. So when I'm finding the length of BC, I use cosine of 23. And that's equal to opposite, I'm sorry, I screwed that up. It should be sine. I just said sine and I wrote cosine. We're going to use the sine of 23 degrees equals opposite over hypotenuse. Again, that's over 1, cross multiply, y equals 40 times the sine of 23 degrees. Grab your calculator, 40 times sine of 23, hit enter, and we get y here to be roughly 15.6 feet. Okay, again, don't forget your units there. All right, so again, solving a right triangle means solving for all missing sides and all missing angles. Here's another one. Again, at this point, the question is the angle of elevation less than 3 degrees? In other words, is x less than 3? My suggestion for you, pause the video, see if you can't answer this question on your own. If you're not sure, if you're not comfortable yet, then just keep plugging along on the video here with me. So anyway, so this is the angle here I'm trying to find. Okay, and now I identified the information I do know. I do know that this 4, and I do know that that happens to be the opposite side. And I also know this 96 here, and I know that happens to be the adjacent side. Opposite adjacent, so SOHCAHTOA tells me to use tangent. Okay, so tangent of x equals opposite 4 over adjacent, 96. And now at this point, again, we're back to square one. We're trying to solve for this angle here. And so I got to get rid of the tan, and the only way to get rid of the tan is to do tan to the -1. All right, inverse tangent out in front. And so what you're left with now, we're right back here. Now we have x by itself, and that's equal to the inverse tangent of 4 over 96. Grab your calculator. So I do inverse tan, second tangent of parentheses 4 divided by 96. Hit enter, and you get that x is roughly 2.4 degrees. Okay, and to answer the question, is it less than 3 degrees? Yes, it is. Obviously, I think we all agree that 2.4 is less than 3. Any questions you have on the inverse trig stuff, bring it to class tomorrow, and I'll gladly go over that and make sure that you're comfortable first thing tomorrow.